Assalamu alaikum wa rahmatullah. We are team 3. Today we present our study, an experimental study on vitamin C dissolution time under varying water type, temperature, and dissolution method conditions. Our team consists of Ahmed Hires, Saud al-Suleimani, Majid Roueshid, Anas Said, and the instructor Dr. Muhammad al-Harkan. Vitamin C dissolution efficiency is critical for pharmaceuticals and consumer products. Our study investigates how three factors, water type, temperature, and dissolution method, affect dissolution time. Using a factorial DOE approach, we aim to identify optimal conditions and provide actionable insights for industry applications. In the problem statement here, vitamin C tablets can dissolve slowly, impacting user experience in pharmaceuticals and beverages. While factors like water type, temperature, and mixing method are suspected to influence dissolutions, their exact effects are poorly understood. So our objective is to quantify these effects and determine the best combination for rapid dissolution. Here in the methodology, we have three factors. The first one, water type, two levels, regular or sparkling, water temperature, cold, warm, dissolution method, stirred and unstirred. And the blocking factor is the members who did the experiments. So we will do 16 we will have 16 combination treatments. And here, as we can see, we have experiment tools. We will have regular water, glass, sparkling water, scaled cup, spoon, vitamin C.
Assalamu alaikum, my name is Anas Said and I will continue presenting effect model. Our statistical model accounts for main effects, interactions, and blocking. Here, the Y represents dissolution time, influenced by water type, beta, temperature, alpha, method of stirring, and their interactions. The model isolates variability from random error. The hypothesis. We hypothesized that sparkling water, warm temperature, and stirring method reduce dissolution time. Mathematically, we tested if the means differ across factor levels. For example, the H naught sparkling equal regular, and the H1 sparkling and regular are not equal. Interaction hypothesis assessed combined effects. Experimental data. Our data reveals stark contrasts. For instance, sparkling water with warm temperature and stirring dissolved tablets in just 57 seconds, while regular water with cold temperature and non-stirring took 177 seconds. This table summarizes all 16 runs, showing clear patterns. For ANOVA results, ANOVA confirmed all main effects are significant. Dissolution method, temperature and water type, interactions like water type and temperature, and the three-way interaction. Members' variability was negligible.
Assalamu alaikum, my name is Ahmed Hires. In this slide, as you can see, the normal probability plot supports the assumption that the residuals of the experiment are approximately normally distributed. This validates the use of ANOVA for analyzing the effects of water type and temperature and stirring method on the dissolution time of vitamin C tablets. Hence, the conclusion drawn from ANOVA analysis are statistically reliable. As you can see here is the residual versus fitted values plot. It shows that there is no symmetric patterns, indicating that the assumption of constant variance and independence are responsive limit. This supports the validity of ANOVA model and confirms that the fitted model adequately explains the variation in vitamin C tablet dissolution time under different experimental conditions. Here, as you can see, the residual versus observation order plot. It indicates that the residuals are randomly distributed over time, supporting the assumption of independence. This confirms that the order in which the experiment was conducted did not influence the results, further validating the reliability and integrity of the experiment data and the ANOVA analysis. This chart presents the scatter plot of the response variable, the solution time in seconds, against the three categorical factors, which are the water type and the water temperature and the dissolution method. The water type, the regular water is coded by 1 and the sparkling is coded by 2, and the water temperature, the cold water is coded by 1 and the warm is coded by 2, and the dissolution method, the stirred method is coded by 1 and the unstirred is coded by 2. These plots help visualize how each factor level affects the response. The scatter plots of response versus factor level visually support the statistical conclusion from the ANOVA. Warm water and stirring water significantly reduce the dissolution time of vitamin C tablets, while sparkling water tends to dissolve slower than regular water. These patterns reinforce the importance of all three factors in influencing the dissolution process and validate the experimental findings.
The box plot showed that all three factors, water type and water temperature and dissolution method, influence the tablet dissolution time. Sparkling water, for instance, tends to result slightly faster and more constant dissolution than regular water, though the difference is modest. Warm water is significantly reduced dissolution time compared to cold water and shows less variability, indicating more constant results. The most pronounced effect is seen with the dissolution method here, where the stirring leads to much faster and more uniform dissolution times than leaving the solution unstirred. Overall, the plot visually supports the ANOVA findings, highlighting that these factors play important roles in tablet dissolution. The interaction charts, the interaction plots reveal that water temperature and dissolution method have a strong interactive effect. Stirring and warm water, these two represent the warm water. Stirring in warm water leads to fastest dissolution times. There is also a moderate interaction between water type and temperature, where the benefit of warm water is greater for regular water. However, no interaction is observed between water type and stirring, meaning the benefit of stirring is constant regardless of water type. These insights suggest that combining stirring with warm water yields the most efficient dissolution process. For conclusion, the analysis of the interaction charts and the ANOVA table clearly demonstrate that the dissolution method is the most influential factor affecting the dissolution time of vitamin C tablets. It has the most substantial statistical impact, with stirring significantly reduced dissolution time, while the other factors like water temperature and water type also have effects, but they are less pronounced. Based on the results, it's recommended that vitamin C be dissolved in stirred, warm, and sparkling water. And these are recommendations also for the industry and future work. Use sparkling water and warm water temperature in formulation. Recommend stirring in product. And for future work, test higher temperatures. Evaluate cost effectiveness of sparkling water. Thank you for your listening.